of cross-sectional area A forms three sides of a square and is free to rotate about axis OO dash. So where the wire, that wire is what you can see here. If the structure is deflected by an angle theta from the vertical when current I pass through it in magnetic field acting vertically, upper density of wire is rho. The value of theta is given by. It's going to be in equilibrium. Actually, it lies in one plane. So we'll do one thing to we'll make it this plane diagram. So let this be P, Q, R, S. So earlier, the rod PQ, it was vertical. And out the B bar like this, and this is PQ. Hope I'm able to give a better diagram with this one. Plain diagram will make it. Now it will get inclined. P, this is Q, this angle B. So this will make an angle theta. No, it's telling it's in equilibrium. It's going to be in equilibrium, that one. So how it is possible? I'm going to pass a current. Let's not bother how that current flows. So there is some mechanism here. I'll connect a battery. A current I will flow in this direction. Okay. A current will be flowing here. So now the BL force you bring into picture, B bar I. Cross-sectional area A. Forms a three, like a side, so let L be the length. Okay, look at the various forces. So first the U will balance, the weight of that should be balanced by the torque due to dipole moment. But here we don't have a complete loop. We don't have a complete loop. If you want, you can bring equivalent opposite current element, or else calculate the force acting on individual arm. Force acting on individual arm. Now, what will be the force acting on the rod PQ? So B bar, okay, current, let's assume that somewhere the current will come here. There's an I. Okay, look at the current I now. The current I will be in this direction. Okay, B bar, there's a current. So how the force will be acting out of the plane of paper. Or you resolve B bar perpendicular to the rod and parallel to the length of the rod. So if you resolve this, one component will come B perpendicular, the other component will be B parallel. So again, the angle theta, this will be the theta. So B perpendicular, B parallel. So B perpendicular should be equal to B sin theta. B parallel should be equal to B cos theta. Force due to B parallel will be 0. B perpendicular, the force will come. Okay, now get into this one. B perpendicular, so how the force will act in this direction. The PQ will perpendicular rod. Similarly, on the rod OR, it will be equal and opposite. The force acting on the rod FPQ and RS will be equal and opposite. Hope everyone is able to understand. B bar, I don't have much directions here. I'm asking you to take how the force will act. Force will act perpendicular to the rod PQ, out of the plane of paper, according to that given diagram. So here that force, I'll show it here in this direction. There's no other way. You have to fight with the diagram here. Similarly, the force acting on the rod okay, this will be S R, the current will flow here. B perpendicular, again same, B parallel. What about the force here? B perpendicular current, so it will be into the plane. So what about the torque due to these two? Will be equal and opposite. So will be, they will not set up any torque about the axis, so this is the axis, no? Okay, though they will act, they'll set up equal and opposite torque. So I need to bother. So what I should bother about only the torque due to QR. Okay, we'll go for the torque due to QR. The current I. So here this will be, rather than this diagram, I'll suggest you go for this diagram. Current will be out of the plane. There's a rod. There's NQ you're seeing, and B bar you're seeing in this direction. Like B bar, current is out of the plane. So therefore the force QR will act in this direction. FR is equal to FPQ, and they'll be equal and opposite. Only torque will be set up by FQR. And that should be balanced by the weight. So let's get into the next part of the problem. Here, what are the other forces that will be acting? Weight mg. Let mass of the each rod, let me take that as mg. Okay, now let's go for the torque about the axis. Torque about OO dash due to weight. What all I should write? mg, length will take it to be L, mg L by 2, mg L by 2 sine theta, 2 times of that, plus mg into L sine theta. Okay, 2 get cancelled, so this will become 2 mg L sine theta. Torque due to the force, BL force. Torque due to magnetic force. So that should be equal to FQR FQR into L cos theta. FQR into L cos theta. And how it will be? It will be in this sense. Both are in same sense, no? Both are in same sense, I think. I think direction of current I should assume in a opposite way. Yeah, let me check it. So this is mg, torque will be like this, clockwise. This torque also clockwise. We should get anti-clockwise. No, I should change the direction of current. You didn't mention anything very random question. Okay, we'll change the direction of current. All things will change. Only the sense of torque will be different. This will be, now this force will become into the plane. This will become out of the plane. Okay, no big difference. This will become out of the into the plane. then B bar current. So this force FQR will act in this direction. Now this will be anti-clockwise. Okay or no? Torque due to dipole moment. So torque due to weight should be equal to this one. So this will become 2 mgl sine theta equal to FQR L cos theta. FQR, what is the value of FQR? That will substitute. So 2 mgl sine theta. This should be equal to BIL into cos theta. One L gets eliminated. So finally, expression for I is equal to 2 mg tan theta by B. The value of theta is asking us tan theta equal to tan theta is equal to BI. We'll simplify tan theta equal to BI by 2 mg. What is M? M is what we assumed it. So that should be equal to density rho A. One more L will come here, no?
Sir, BIL square.
Yeah, BIL. BIL. What is M? M should be equal to rho E has given density rho A into L. Tan theta equal to BI 2 rho AG. Very good problem. Student really has to put lot of effort here. Okay, make observation. Okay, the direction of current, we just assumed it. Okay, afterward the net torque was non-zero. I changed the direction of current. Okay, no. This is one more problem I'll give. So somebody. This one will take one more similar to first problem.